So we're looking at rates of change here. We can use the chain rule to connect rates of change in situations that involve more than two variables. So in this instance here, I've got an equation. It says given that the area of a circle A centimeter squared is related to its radius r by the formula a equals pi r squared, and that the rate of change of its radius in centimeters per second is given by dr by dt equals 5. So what we need to understand is what a rate is. Now, a rate, whenever they mention the word rate, is always associated with something that changes with respect to time. So something that changes with time. So a rate will always be something over dt, something by dt. That's what we expect it to be. Something, whatever they're referring to, over dt. So if they say the rate of change of radius, it will be dr by dt. If they say the rate of change of area, it will be dA, A representing area, by dt. So we need to understand that rate means something changing with time. That's very important to understand. Now, if you remember the chain rule, we're going to be using the second skill that we're going to be using here is the chain rule. The chain rule states that dy by dx is equal to dy by du times du by dx. And how the chain rule works is by understanding that what we have on the numerator, dy, there's a dy there, and what we have on the denominator, dx, and if you can see here on the right hand side of this equation that I've got, my du's would have cancelled out with each other, leaving us with dy by dx. So a chain rule works by connecting rates. So we've got one rate here and one differential here and another differential here. I shouldn't use the word rate unless it's by dt. A differential is anything that involves dy by dx or dx by du by dx. Anything that involves rates of change is actually a differential equation. Anything that involves rates of change. So at the moment, this here, I've got dy by dx, so one kind of a derivative and another derivative, and they're connected together. If we multiply them, it gives us dy by dx. So this is our chain rule. So we're going to be using the chain rule and understanding the word rate to then go and answer this question. So it goes on. Let's have a look. We'll go and approach this a little bit at a time. So it's given us the equation for area. It's given us that dr by dt is equal to 5. So it's given us a rate here, and it wants us to find out what dA by dt is. So whatever we're after, I always go and highlight that first. I'm after dA by dt, so I'm going to go and make a note that this is what I'm after, dA by dt. So I want this. Now, in order to get this, I'm going to use my chain rule and I'm going to think about what I need on my right hand side of the equation. So to get dA on the numerator, as you can see here, I've got dA on the numerator. I need to make sure that I have dA on the numerator on my right hand side on something. So I'm going to look at my equation. Do I have anything that involves dA? Well, at the moment I don't, but can you see here I've got an equation involving A and R. So using this equation here, I can go and find out a derivative for this. So I can start off by saying A is equal to pi r squared, and I can differentiate with respect to r here. Differentiate A with respect to r. That gives me dA by dr is equal to, we're differentiating with respect to r, remember, so it will become 2 pi r. So here I've got a differential that involves dA, which is what I want, and I also want to end up with a dt on the denominator. Now, if we look at our dt on the denominator, we can see that there is already a differential given to us. The derivative dr by dt equals 5. So we've already got a differential involving dt on the denominator. So I want dA by something. Well, can you see here I've got an equation that is dA by dr, so I'll write down dA by dr from here. I'll highlight that. So there's my dA by dr. And I also want something that involves t in it. And I can see here I've got another one here, the dr by dt, which I'll highlight just to make it clear that I want this dr by dt. And if I take that there and write it down here, I'll write it down as dr by dt. Let's see if that actually works. If I did multiply them out, can you see my dr's would have cancelled out and I would be left with dA by dt, which is what I have on the left hand side. So my left hand side and right hand side match. The equation is balanced. So that's a way of checking if we are getting the correct equation. So now once we've got it into this form, we can go and substitute what we know. dA by dr, as we know, is 2 pi r times dr by dt, which we're given there, is 5. So this then simplifies to 10 pi r is what dA by dt is equal to. And the question wants us to find dA by dt when r equals to 3. So the substitution of r equals to 3 comes in now. Okay, we wouldn't do the substitution earlier, so then we can go and say 10 pi lots of, replace the r with 3, and that gives us 30 pi, which is our answer. Okay, so that's how we look at rates of change, where we are essentially connecting different rates of change involving more than 2 variables by using the chain rule.